everyone, my name is Tommy Hoover, and today I'm going to be teaching you how to use U substitution. So the goal of U substitution is to reverse the chain rule, and it also helps us integrate, big composite functions with tons of variables in them. And so one of the biggest questions that comes up when doing a U substitution problem is figuring out what U to use. So when you're looking at an equation or a problem that you have to use U substitution with, here are a couple things that you want to keep in mind. You want to look to see if there is a duplicate of a set of numbers or equations with variables. Like if there is an x squared plus 2 on the top and on the bottom of a huge composite function, that will be your U variable, as well as look inside of parentheses. So if you have a problem that is 7 tan parentheses 2x, 2x will most likely be your U variable. So keep those two things in mind when looking for your U. Okay, so before we begin practicing our U substitution, there's one very important thing that we need to know how to do, and that is how to take an antiderivative. And at least I like to think of an antiderivative as, well, just like the opposite of taking the derivative. The derivative kind of makes the function smaller. The antiderivative makes the equation bigger, right? So we'll do this pretty easy one out, and it's x to the third plus 5x squared minus 3x plus 7 dx. And so what we're going to do is we're basically just going to take, so the x, you got x to the third. So to make the x to the third bigger, to take the antiderivative of it, we are going to raise it now to x to the fourth. We're going to add a power to it. And when you add the power to it, you have to divide by that number that you just added to it. So for example, you got x to the third is now going to change into x to the fourth over 4. So it's basically just adding one power and then dividing by whatever number that just gave you. So for the next one, it's going to be plus 5x squared is now going to turn into 5x to the third divided by 3. And occasionally you will get one where you can simplify the numerator and the denominator, and you need to do that when that's necessary. And so for the next one, 3x is going to change into negative 3x squared over 2. And then finally, 7 is just going to turn into 7x. And you can think of it as 7x to the 1 power over 1 if you want. It's the same thing as just writing 7x. And then you have to finish it off with plus c. So when taking an antiderivative, there are many special cases and other things that you need to know that will appear in certain problems. For example, sine, cosine, tan, secant, cotangent, all those will appear in U substitution problems. So you need to know what these special cases are in order to successfully answer the problem. There really is no way of learning these. You kind of just gotta drill them into your brain, which is a little tedious, but that's just what you gotta do. Okay, so here we have the problem 4 cosine 2x dx. So the first thing that we're gonna do, as previously mentioned, is try to find what our U variable is. We're going to look into the equation and see that we have parentheses. So our U variable is going to be 2x. 2x. Now what we can do is find our du. And the du just stands for the derivative of the U variable. So it's the derivative of 2x, which simply equals du equals 2 dx. Pretty simple. But now we want to get dx alone. So what we can do then is divide 2 by dx and 2 by du, leaving us with dx equals du over 2. So now we can kind of start to play around with our equation. So first thing that we're going to do is take out the 2x and replace it with a u. We are then going to replace our dx with what we just figured out, dx equals du over 2. We're going to replace the dx with du over 2. So now we can kind of start to simplify our equation by dividing 4 and 2 to just be left with 2 cosine u du after everything's done. Now what we're going to do is take the antiderivative of cosine. And the antiderivative of cosine in this equation is going to be sine. So we're now left with 2 sine u, and then we're going to take the du and just replace it with plus c. But we're not done yet, because our last step is to add back in our u, which once again is 2x. So we are finally left with 2 sine 2x plus c. Okay, so we now have a little bit of a harder problem of 5x squared, parentheses, 3 minus 10x to the third, and then that is going to be raised to the fourth power dx. And so we're going to look for our parentheses or our equation side of equation or whatever it is, and we actually have both of those two things, so it should be pretty easy to tell that our u is going to be 3 minus 10x to the third. And now we're going to find the du, and the du is simply going to be negative 30x squared dx. So now we're going to kind of separate the two functions of the equation up and disregard the negative 6 for now. So just looking, we should have just 3 minus 10x to the third to the fourth and 5x squared dx. But we're now going to look to see what in that function can we use to equal our du of negative 30x squared. And that's going to be the 5x squared. So what times the 5x squared is going to equal negative 30x squared? And that's obviously going to be negative 6. And so we're going to move a negative 6 over to the left to balance it out, or sorry, a negative 1 over 6 to balance it out. And so we're then going to replace 3 minus 10x to the third with our u, like we did in the last problem, to get negative 1 over 6 u to the fourth du. And now we're going to take the antiderivative of that u to the fourth. And we're going to get negative 1 over 6 u to the fifth over 5 plus c. And so we can then kind of multiply the negative 1 over 6 times the u to the fifth over 5, and we're going to get, after then also plugging in 3 minus 10x to the third for our u again, we're going to finally equal, have an equation that equals negative 1 over 30, 3 minus 10x to the third raised to the fifth power plus c. And that's going to be your final answer.